Hello, geometry kids. Sorry I'm not at school today. So I thought the first thing we should probably do is go back and review some of the 30, 60, 90, and 45, 45, 90 triangles from last week, because that was something that we were still a little bit confused on. So I have a couple of examples here we're going to go through. And what we have first here is a 45, 45, 90 triangle on the left. And we know that this side and this side are the legs. Well, if the legs it's an isosceles triangle, which means the legs are the same. So if one side is 5, then y is also going to equal 5. Now to figure out the length of that hypotenuse, remember our rule was we have the legs are the same, and the length of the hypotenuse is the length of the leg times the square root of 2. So this would be 5 times the square root of 2. Notice when we do these, we have this is 5, and that's 5 times the square root of 2. Over here on the right, we have a 30, 60, 90 triangle. We have to look at the piece that we know that they give us. Right now we know that the hypotenuse is 16. Well, if we think over and look at our poster over there on the board or over on the windows, if we have the hypotenuse is 16, we know the short side, which is opposite of 30, is going to be half that. So we're going to know this is 8. And then we have to remember our rule for the long side. The long side is going to be the short side times the square root of 3. So it's going to be 8 times the square root of 3. So we just have four more examples here just to go back through and practice just a little bit. And on the first one, we have 45, 45, 90 again. And if you notice, it's giving us a leg one more time. So we know if that's 7, P is also going to equal 7. And if those two sides are 7, the hypotenuse is just the leg times the square root of 2. And on this next one, it gives us the hypotenuse is 8. If we know the hypotenuse is 8, we know that the legs are the length of the hypotenuse, basically divided by the square root of 2, because on the first one it is the length of the leg times the square root of 2. To go the other way, it'd be dividing by the square root of 2. But when we do that, if we have 8 divided by the square root of 2, we have to rationalize it, which means we have to multiply the top and the bottom by the square root of 2. And we get 8 times the square root of 2 over 2. And since they are both outside of the outside of the radical there, 8 and 2, we can call that 4 times the square root of 2. So the length of y here is 4 times the square root of 2, and if we know that's 4 times the square root of 2, the other leg is also the same, also going to be 4 times the square root of 2. On the next one, we've got a 30, 60, 90, and we know that we have the short side is given to us, and we know that if we have the short side, the long side is going to be, not the long side, excuse me, the hypotenuse is going to be twice that. So if the short side is 2, the hypotenuse will be 4. And then the rule we need to remember is that the long side, which is s in this case, is going to be the short side times the square root of 3. So we're going to have 2 times the square root of 3. And on our last one here, again, we have to think about what side is given to us so we know where to go. Well, we have the hypotenuse is 6. Okay, well, we just talked about on the last one, the hypotenuse and the short leg are related to each other. So if the hypotenuse is 6, that means the short leg is half that, which is 3. And then we also know that this long leg, W here, is going to be the short leg, 3 times the square root of 3. And the more you work with these 30, 60, 90, and 45, 45, 90 triangles, the easier it becomes. So just have to keep working at it. Okay, so now the new topic for the day is a geometric mean. And if you remember, for forever, we've talked about mean, meaning average. Well, in that case, it's the arithmetic mean, and that's when you just add everything up and divide by however many in your list. Well, now we're going to talk about the geometric mean, and the geometric mean is written as a proportion. Okay, so as you look up here in the core concept, it says that that a and b is positive number x. It satisfies a over x equals x over b, so that x squared equals ab. The way that I think about it is that when it asks you what is the geometric mean of two numbers, I always think of it as a proportion, okay? So the first thing we're going to do is just write ourselves a proportion. We have fractions on each side. When it's asking what is the geometric mean, okay, that geometric mean that we're trying to find, that unknown, goes diagonal from each other on the proportion. So what the geometric mean is going to be like the x's up here in our formula, and then the two numbers we're finding the geometric mean of go in the other two spots. So we have 4 places to fill. 2 of them will be the same, okay, because that's how we get the x squared equals a times b, like up here. And then when we go ahead and do our cross multiplying, we get x squared, or our butterfly method as some people like to call it, x squared equals 100, and if you take the square root of both sides, you get that x equals 10. Okay, and then again, it's asking what is the geometric mean. Okay, so if it's asking what is the geometric mean, we're going to get our proportion. We don't know what the geometric mean is. Whatever the geometric mean is, even if it tells us the geometric mean, we put the geometric mean opposite corners of our proportion. And then the two numbers we're using to find the geometric mean go in the other corner, like that. So then when we cross multiply, we would get x squared equals 40. If we take the square root of both sides, we would get x equals the square root of 40. Now keep in mind, when we do this, we have to simplify our radical, which we did. We practiced that. We could break that up into the square root of 4 times the square root of 10, which is 2 times the square root of 10. Oops. Put the wrong number there. That meant it should have been 2 times the square root of 10. Okay. So just some extra practice ones here. If you want to pause the video and try it on your own, you certainly can. Remember, you're finding the geometric mean of these two numbers. Okay, so that means we're going to set up our proportion. And the geometric mean, find it means what is the geometric mean? We're going to put the value we're trying to find, the geometric mean, in opposite corners. And then we're going to put the two numbers we're using to find the geometric mean on the other corners. And if we cross multiply, we get x squared equals 256. If we take the square root, x equals 16. All right, last one. Again, find the geometric mean. Set up our proportion. Put our x's in the corner. And then we're just going to have the two numbers we're taking the geometric mean of in the other two corners. X squared equals 36. X equals 6, because we're going to take the square root of both sides. Okay. You can also use the geometric mean to find the length of an altitude. So remember, the altitude in this triangle here is from the vertex perpendicular to the opposite side. So that blue highlight is the altitude. And they give you a formula for it. I always think about it as a proportion. Anytime I'm doing anything with geometric mean, I always think proportion. So I'm thinking, all right, I'm going to set up my proportion, okay? And it says the altitude, in this case in this diagram, is x, is the geometric mean. Well, we put our geometric mean in opposite corners, so we're going to have x and x. And in this case, when you have an altitude, it is the geometric mean of the two parts that it intersects. So it's going to be the geometric mean of 6 and 3. So when you cross multiply, again, you get x squared equals 18. You take the square root of both sides, you get x equals the square root of 18. And of course, we always want to make sure we simplify that, the square root of 9 and the square root of 2. So in this case, x is going to be 3 times the square root of 2. Okay, so we just have a little bit more practice here with that. On this first one that I have drawn, again, the altitude is the geometric mean. So that altitude, which is in red, is x, is going to go in the opposite corners. And then the two numbers that I am finding the geometric mean of go in the other two corners of my proportion, and I get x squared equals 100, so x equals 10 when I take the square root of both sides. And of course, like always, life is not complete if you don't put a little bit of algebra in there with some other variables and stuff. So in this case, we have to think about, it's not telling you that x is the altitude, or X is the geometric mean, or anything like that. You have to think about what information is there. So I know that this length 12 is the altitude. All right, so sorry about that. But so we have the altitude's length is 12. And remember, the altitude is the geometric mean. So that 12, which is the geometric mean, is going to go in a pair of opposite corners. And then the two parts that it is the geometric mean of, a plus 5 and 18, go in the other two parts of our proportion. So I'm going to have a plus 5, and I'm going to have 18. So then, again, at this point, we should be getting pretty good at this. We cross multiply, you get 144. And just make sure when you cross multiply the other way, that 18 gets multiplied by everything, not just the a, but also by the 5. Okay. And so we would have 144 equals 18a plus 90. If we subtract 90 from both sides, we get 54 equals 18a. And if we divide both sides by 18, we get a equals 3. Okay. Okay, so now this one is a little bit different. If you notice, this one has to do with the leg. And remember, the leg is the two pieces that make the right angle in the triangle. So in this case, in our triangle that we are looking at, these two on the big triangle, those two are the legs. But right now, if you look at y is a leg. And it's saying up here that the leg is the geometric mean of the two parts on the other side. Now listen carefully, because it's going to be a little bit different. It says that the leg is the geometric mean of, let's look at this, the two pieces that it touches. That's the way I like to explain it. It's the pieces that it touches. So it touches 2, let's pick a different color here, 2. It doesn't touch 5 all by itself. It touches the whole length of the hypotenuse there. So the length that it touches is 2 and 7, not 2 and 5. If we were using that altitude in the middle here like that, then the altitude would be using 2 and 5. But in this case, since it's the leg, which is y, is the geometric mean. So y is going to go in our opposite corners of the two pieces it's touching. It's touching 2 and it's touching 7. Again, it is not 2 and 5. So you have to look at what piece of information is given to you so you make sure you have the right thing. So you have y squared equals 14 and y equals the square root of 14. Okay, that one gets kids all the time. Okay, so we have two things here. We have to think about what actual information is given. Okay, y is an altitude. Okay, so y is an altitude. So we want to think y, which is the altitude, is the geometric mean. Okay, so y is going to be the geometric mean. Before I tell you, I want you to think for just a second. What's it the geometric mean of? Okay, we want to think that the altitude is the geometric mean of the two pieces that it touches. So in this case, it's going to be 3 and 9. And again, then you can go ahead and finish out the proportion like you've done 10 times already today. I'm not going to do that again. You'd have y squared equals 27. You'd have to simplify the radical. The other one is x. Okay, x is a leg. Okay, and the leg is the geometric mean. So again, we're going to go ahead and make our proportion. X is the geometric mean of the two pieces it touches. Okay, so it touches, 3. That was supposed to be a highlight. Hang on. It touches 3, and it touches the whole thing, not 9, because otherwise you're going to get the same answer. And obviously x and y are not the same length. It touches 3, and it touches 12. Because 9 plus 3 is 12. So then when you cross multiply, you get x squared equals 36, and x equals 6 when you actually go through and finish that all out. Okay, last one over here, and then I believe we are done. We have x, y, and z. So you have to actually figure out all of them. You have to think about everything that you know so far. okay? So as I'm looking, if I'm talking about let's pick one of the things we've talked about. We've talked about altitude, right? So we know the altitude is 12, okay? So the altitude is the geometric mean. So I can say, set up my proportions, the altitude, which is 12, is the geometric mean. So it's going in opposite corners. What is it the geometric mean of? The two pieces that it touches, in this case x and 16, okay? So x is going to be, so we take 16x equals 144, and if we divide by 16, we get that x equals 9. Okay, so I have x, now I know that x is 9, so I can go ahead and put that information in there if I want to. I can say that x, I'm going to cross that out, is 9. Okay, now we can do a couple of different things. If we want to find y, there are two different ways that we can find y. Okay, we can find y just by using the Pythagorean theorem. Okay, we've done the Pythagorean theorem. If you notice, this right here is a right triangle. Okay, which means I could say 9 squared plus 12 squared equals y squared, because y in this case is the hypotenuse of that little triangle. If I say 9 squared is 81 plus 144 equals y squared, I get 225 equals y squared, and y equals 15. Okay, so now I know that y is 15. We also, erase that, could have used the geometric mean. Y is the geometric mean of the two pieces that it touches. So another way to think about it, there we go. I'm going to do that up here a little bit. Another way to think about it is y is the geometric mean. So I'm going to go ahead and say, I said y, my leg is the geometric mean of the two pieces that it touches. Well, it touches 9, and it touches the whole thing, which is 25. So I get y squared, and if we do 25 times 9, we get 225. And if we take the square root, y is still 15. So you can use the geometric, once you know some information, you don't have to use geometric mean. You can look at it and say, okay, do I want to use geometric mean or do I want to use Pythagorean theorem? So when we go to find z, we could either say, let's see, we'll make z this triangle right here. If you notice, it's a right triangle, and it's got legs that are 16 and 12, and the hypotenuse is the value of z. You could also use the idea that z is the geometric mean of 16 and 25, because it's that. So let's look at it both ways, just to make sure that we see how that works. If we say use the Pythagorean theorem, so we're going to come up here, and in blue, okay, if we use the Pythagorean theorem, we'd say 12 squared plus 16 squared equals z squared, because that's just a right triangle. So we'd have 144 plus, let's see, 16 squared, 256, and so we'd have 400 equals z squared, and the square root of 400 is just 20. Okay, so we could use the Pythagorean theorem. The other way that we could do it is we could say that z, which is the leg, is the geometric mean, so I'm going to put that in the opposite corners, of the two pieces it touches. Well, z, this corner here, touches 16, and it touches the whole thing, which is 25. Well, if you take 16 times 25, you get 400, so you'd have z squared equals 400, and z equals 20. So it works both ways. And if you like the Pythagorean theorem better, once you get enough information, you certainly can use that. But sometimes you're going to have to use the idea of the geometric mean with the leg or the altitude to get enough information to do that. And not that you are dying to do any homework, but there is a homework assignment in Big Ideas. It is 9.3, so please complete that and make sure it gets submitted by tomorrow. Have a good day.